as soon as compute power goes up, the problem complexity space also increases, right? So you end up with, with a similar sort of performance characteristic, even though you've gained computing resources. And I think this is also interesting because, as you mentioned, like the changing market needs or the changing landscape, that happens equally as fast as compute resources are become available, right? Or as compute resources improve. In fact, I'd say it even happens faster. There's something to be said for understanding how to iterate quickly. Like, can you take smaller sets of data and a smaller model and smaller amount of compute and get sort of a finger in the wind result that gives you a signal whether you're going in the right direction? I think those things are super important.
The following is a conversation with Bo Archer, senior software engineer at Rad AI. Bo has done some incredible work and is most well known in the industry for his expertise in engineering excellence, infrastructure optimization, and platform success. Dear listeners, thank you so much for tuning in, and please join us in imagining the future. Welcome, Bo, to the Imagining the Future podcast. We are so excited to speak with you today. Can we start by hearing a little bit about you and what you do at Rad AI?
Sure. Good morning, Dr. Sai. Thanks for having me. I'm a software engineer. I've been so for the past 25 years and worked across several industries. And I lead the platform group at Rad AI, which is our core services, data, and infrastructure teams.
That's amazing. Can you tell us a little bit about what it means when you say platform group, just for our general audience that might not be as familiar with it?
Yes, absolutely. So the platform group is a group of software engineers and data research scientists and data engineers who support all of the internal systems that are used by the Rad AI product.
I see. So, especially because the Rad AI product line is in a pretty crucial aspect of, medicine and clinical delivery and also tech, those intersections probably require a pretty dedicated team to keeping that secure, but also reliable. And can you kind of delve into that a little bit?
Yes, absolutely. So you're absolutely correct. We do manage very pivotal systems, including our inference, including all our data and intelligence. And a lot of these things enable not only users to use the products, but also enable engineers to manage the products, enable engineers to debug issues. And obviously, when one of these systems goes down or has a problem, it's a big deal and absolutely does require a dedicated team in order to be available to make sure that things continue working.
Yeah. It's interesting. I read a reference recently about how products, especially in the healthcare and clinical and AI space, have to be near perfect at all times because obviously the stakes are very high, and it's this idea of building bulletproof systems, and of course understanding that no system is perfect, but still striving for a bulletproof system in some sense. Could you tell me a little bit about what that means to you and what a bulletproof culture kind of entails and what that mainly means at a generative AI company?
Yeah, absolutely. And you're absolutely correct. The expectation from our users is that our software is reliable and near perfect, as you mentioned. And though that's not always the case, there's always a time where you will uncover a gap. But from the starter perspective, when you build something, it's almost never going to be bulletproof on the first time out. So being bulletproof is an iterative process, but it also requires dedication. It also requires honesty and ownership. So, you may build a new product or a new system and you may think very hard about what it means for that to be bulletproof. And you may implement a lot of things which you believe make it bulletproof. And then your customers will use it in some way you didn't expect. And you will uncover some issue that makes it not bulletproof. And I think that what's important about that is recognizing it very quickly and figuring out how to close the gap. that's, like I said, an iterative process that we're doing all the time at Rad AI. Our reporting product, which is our flagship product, we spend a lot of time as we deploy this product trying to make sure that it's reliable every time. And when there are issues, we are immediately on it, right? Looking for how do we mitigate this in future? How do we make sure that we're alerted of this more quickly next time? It's a continuous process.
Yeah, that's really interesting because I think what you mentioned is a really important piece. I think for people to understand, especially if you're not too familiar with the tech space. What's important is it it's not always about standardizing tools and optionality. Sometimes, to your point, there's new use cases and I guess edge cases and corner cases that emerge all the time in tech. That when the product was built, you can't possibly imagine all the different potential use cases for it that a user might use it for. So I think that's probably what makes the work incredibly challenging, but also incredibly intellectually stimulating as well. How do you feel? I mean, and I think you started speaking about this a little bit, but how do you feel like this culture and this mindset has been implemented at Rad AI? And kind of what is the? I know you spoke a little bit about reporting, but generally speaking, maybe for reporting or beyond the other products as well, how has this culture kind of been imbibed in it?
Well, I think we start with, no blame culture at Rad AI. So immediately when we approach building systems and with the understanding that there could be a flaw or there could be a use case we didn't understand, the first thing that we think about is being open and owning, right? We don't providing a culture where there's no fear of being blamed and there's no fear of it's okay to make a mistake. That allows us to move past lengthy and invaluable discussions when something does go wrong, and allows us to, immediately address the problem and, pull in the right people and get the transparency we need to address it. I think that's one of the most important things. You'll definitely find other companies don't have similar culture like this, and I definitely feel like there's a big difference to how engaged we are with our customer, how engaged we are with our systems, between a culture of no blame versus a culture of blame. So I think that's really a key aspect here, of going into the bulletproof culture. You know that you may have a small bulletproof vest on, but maybe you need a thicker one in the future, and it's okay to make that transition, and it's okay to notice when you need to do that, and no one's at fault, right? And I think that just makes the whole process smoother and I don't know, more enjoyable, more engaging.
Yeah, I think that's absolutely correct. You know what's interesting is you think so much about how to set up this culture, but I think in a product basis too, there's so much work that goes into um, setting a product up for success, especially when you start thinking about very crucial products like impressions, which is used by a huge population of radiologists. Rad AI's uh, first and most prominent product, and then reporting, which has kind of become incredibly important and in continuity. These pieces are so have become so crucial to the radiologist workflow now. What do you think it means to set up a product like that, or just a product in general, for success? And what are some early mistakes that you've seen in building generative AI products generally, and how can teams kind of avoid them?
I think that's a great question. I think, you know, putting my product hat on for a minute now, I will caveat that I'm not a product person, but I work with lots of them. And I think setting up a product for success from the beginning is really about understanding what your customer needs, right? It's about understanding where you can make an impact for them, where you can add value, and really building a moat around those things, right? And I think, in general, Rad AI has done a pretty good job of that. Especially with the reporting product. There's not another product on the market that's quite like it. And I think that that comes from really focusing on the needs of customer. And I think it's not just the needs of one customer, like having impressions, reporting, and continuity as a suite of products. Each of them are addressing slightly different things. And even if you take continuity, for example, it's addressing a use case that doesn't even necessarily have to do with radiology. So really understanding the end to end needs of a group of customers who are all trying to achieve something or one specific outcome. In the case of like continuity, we are looking to enhance the follow up process so people don't get lost. After they go see a radiologist, they might have some follow up that's required. Sometimes they don't. They don't engage with their doctor to get that follow up, and they're lost in the system. So we're helping another group of nurse navigators to close that gap. So understanding the end to end is another part of it, I think. And the more we understand that end to end, the more we can sort of see where business impact is available or where we can really add value. So as far as setting up the product for success, I think that's the biggest thing. Um, and I think from early mistakes, I'd say the way to categorize this is, if you don't know the needs of your customer and you're not really aware of the needs or the business impact that you're trying to achieve, it's very easy to get lost in generative AI. Generative AI can do so much. It can, you know, you could experiment with different things for months and months and months and never come up with something valuable, or you could hit the jackpot accidentally. Right? It's generative AI is very vast and very dynamic in this way. Uh, and because generative AI is really so expensive to maintain and to push forward, it's super important that you know the needs of your customer first, right? So that you end up spending the time and the effort and the resources, the money in the right places, because it's it's not something that you can easily rapidly iterate on and get really good results, right? Model training takes time. It takes a lot of data, right? In order, you have to gather all that data to train those models. So if you gather all the wrong data and you train the model on something that doesn't have business impact, it could be a huge waste of resources, right? And I think those are the things that I would tell any early company to watch out for.
Yeah, I think that's really interesting, right? I think um, there's a couple pieces there, right? I think it takes a lot of work to get a product out and to ship to the point where there's almost like this developer's paradox of, shipping quickly, but at the same time being able to reiterate quickly and at the same time innovating quickly based on, changing market needs. So it's a very, very challenging paradigm at the
Hmm.
confluence of those three. And, there's that adage in Silicon Valley, which is move fast and break things that dominated so much of, the late 2000s and early teens of when these big companies were coming to life. And so I think now in the paradigm of generative AI, hopefully, I think as Moore's law and cost of compute continues to go down exponentially over the next 10 years, it will be easier to move faster, break things quicker, iterate quickly, but definitely appreciate how hard that is for a team that is so hyper focused on customer success, customer reliability, but at the same time maintaining the highest degree of innovation. So,
Yeah, 100%. I definitely think, you know, it's interesting to me because as you mentioned, like things like Moore's law, for example, uh, there's also another side of it, right? Where, as soon as compute power goes up, the problem complexity space also increases, right? So you end up with a similar sort of performance characteristic, even though you've gained computing resources. And I think this is also interesting because the as you mentioned, like the changing market needs or the changing landscape, that happens equally as fast as compute resources are become available, right? Or as compute resources improve. In fact, I'd say it even happens faster. So we tend to get lost, I think, there. I still think the same thing holds. Like you, it will be expensive, and you will be trying to solve complex use cases, which will require massive compute time, massive costs, and I don't think that will change too much. Although I do think there's something to be said for understanding how to iterate quickly. Like, can you take smaller sets of data and a smaller model and smaller amount of compute and get sort of a finger in the wind result that gives you a signal whether you're going in the right direction? I think those things are super important. I think we do that often here. We might spin up a model off to the side that isn't taking high traffic, and maybe we'll take some of our data and feed it to the model and try to get a finger in the wind understanding. There are definitely opportunities for rapid iteration, Um, but it's sort of a logarithmic return, right? Uh, it's at some point, right? You're going to put a lot of resources into the model for not a lot of additional benefit.
Yeah. It's the marginal utility curve of that diminishes at some point. It's interesting that now that we've started talking a little bit about the compute piece, so much of the generative AI discussion now has turned to infrastructure.
Mhm.
To talk about data centers, we talk about energy consumption. At the same time, it's become so easy using larger model wrappers to dish out apps really quickly by the general consumer. But what's not easy is to scale and to scale, especially in a very sensitive world such as healthcare that has, you know, very sensitive data, very specific regulatory pieces. And also, I think most importantly, at the end of the day, directly translates to clinical and patient outcomes, right? People depend on the product for very real outcomes. How do you feel how do you feel that infrastructure has played a role? I mean, it's obviously very critical, but how would you kind of explain how critical it is really to building out good, reliable, and trustworthy AI tools?
Well, I think it's substantially critical. So before AI models were a big thing, and we can go back to the early 2000s, a lot of your services were basic REST, right? You make an HTTP request, you get an HTTP response. There's an expectation of latency to be, a second or less to get back your data resources. And a lot of the web architecture is built around this assumption. Sure, like gaming might be an exception where a lot of your multiplayer online games are built around WebSockets and real time communication. But even still, those payloads were generally small, and the response times were generally very low latency. Take a game like Battlefield, for example. You have people running around a map and shooting bullets at each other. The server events volume is very high and has to be very, reactive. But these are very predictable, right? So we can scale predictably for things like this. With an AI model, inference is not as predictable. There may be time where you run inference on an input and you get back in half a second. Where there may be another time where you run inference on an input and it takes 10 seconds for the model to figure out what the answer is. And there could be any number of reasons why, right? So, from the infrastructure perspective, this requires a whole different architecture in order to really power this. You can take ChatGPT, for example. When you put a prompt into ChatGPT, it gives you the little spare, it's thinking for a minute. And then as the answer comes to you, it's being generated, it's streaming back to your client in real time and it's coming back in chunks. Right. So it's a whole different way of thinking about what does it mean to give a request and to get the full inference response. It's a set of requests and responses. ChatGPT uses server sent events to achieve this, which is kind of akin to WebSockets, where a server can send back something to a client when it's ready. The client isn't pulling for it or it's not maintaining necessarily an open HTTP request for this amount of time. So it sort of changes the game a little bit. And the second thing is that, models are very sensitive to concurrency. So, if you have too many people running an inference at the exact same moment on the exact same model, you can really quickly exhaust the model resources and compute, and you can start to see, your latency for your responses to go way up. And in the world of radiology, where a lot of our inference comes from speech dictation, it can be very jarring if the inference response doesn't happen in a very short amount of time, sometimes less than 3 or 4 seconds. If it's beyond that, then it's not useful to the radiologist. They might as well just type it. And this is always a battle we're fighting here, right? And so I think the infrastructure plays a crucial role, not just the resources that we deploy at the network level, but also at the software level, how the engineers choose to communicate between systems, how we consider things like rate limiting or consider scaling horizontally our models. It's always a challenge, right? Especially for models that have a lot of traffic, and especially in our case where we want to have a tailored experience for every radiologist, right? So we have to consider this in our architecture as well. Um, One radiologist may say a sentence and have a different, want it to have a different meaning than another radiologist, and the models take care of that.
Yeah, there's so much to unpack in what you just said. I mean, the first thing is I think you had referenced video games. It's interesting because so much of I don't know if people realize like so much of today's tech stack. Everyone talks about GPUs and why they how GPUs are basically powering the entire AI economy right now. It's one of the most important aspects of the stack. But so few people realize that, GPUs, a big aspect of why they were originally created and why they're so successful is because they were run for these very complex gaming engines that you had mentioned, right? And so it's interesting that the heavy load of gaming and the experience that made gaming so I guess compelling is the same motivation that triggered the built of even better tools that eventually translated to now being recycled or reused functionally for the very heavy workloads of generative AI.
Hmm.
The other piece I think you mentioned that was really interesting was being able to tailor so some of the products like impressions or even reporting, tailors to the voice of the radiologist, as in the personality or how they kind of dictate, right? And that is a very complex piece. And it takes so much work across teams to be able to bring that together to an end product. Do you have any thoughts or advice or maybe even pearls of wisdom on how you feel like your approach is to keep teams aligned when working on complex pieces like that, or even just generally when working across teams like engineering to product managers to deployment solutions, et cetera, when you're working on such intricate products, what is your approach to keeping teams aligned and approaching the vision in a cohesive front?
Yeah, I think what's really important is, again, going back to impact and results, right? Starting from there, right? And what is it you're trying to achieve and what is crucial for the use case? And I think from that point, it's really about getting together a small group of people who have the capability to think about the architecture end to end, starting to sort of identify crucial points of contact between systems, to identify how they should interact with each other, sort of going down the path of having those deep discussions with the teams who will eventually own the implementation there, right? I think drawing a map is super important and getting everyone aligned on that map. And then once you're able to do that, as far as like dividing and conquering the work, that becomes very similar as building any software. But again, I think, regardless of the fact that AI might use different patterns or different architecture to achieve what we achieve here, the process is the same, right? It's really about getting in alignment early on before even going into the weeds, right? And each layer of the process, starting with the high level of what you want to do, what you want to impact, what is it we're building, and then getting into the aspect of like, okay, what are different ways we can achieve this? What are the trade-offs? What are the pros and cons of each approach? We go through that cycle just like we would with designing any other software, and really trying to get into those conversations long before any lines of code are written. And then, of course, there's always testing your assumptions, right? There's always times where it might be, okay, we have this theory, we have this idea. Can a group of people from these teams go off and create it as sort of a theoretical test or a POC that can prove this out? So sometimes we have to do that and come back and gather the data and figure out if our original assumptions still hold. Again, it's an iterative process. But once you get to a point where you're like, okay, I think my assumptions hold, then it's all about execution, right? And making sure that you get out of the way as much as possible so the teams can execute on their pieces. And then, of course, towards the end, uh, it's a lot of testing, right? It's a lot of, we do this plan up ahead of time so the teams know what's coming. But I think once we get in alignment there, a lot of it's get out of the way and execute, come back together, test the assumptions one final time. And then it's all about releasing to the customer, getting their feedback as well. But the entire time we should be thinking about the customer and what they need, right? And I think if we have that in mind, it becomes a lot easier to get teams aligned on what it is they're building or how we should build it. Everyone thinks in the same way of like, what is the purpose of this thing I'm building? The alignment kind of provides itself in a way, I guess, right? And suppose people are thinking the same way. You don't have to work hard on getting in the line.
Definitely. I think the key takeaway for me, kind of from your experiences, is constant alignment, frequent testing, and always, always, always a mind to customer success and what the customer at the end of the day is most important to them, right? And I think those three paradigms ultimately dictates a really solid product or engineering, or I mean all of the above really dictates the ultimate culture. Um, I guess one last question for you. Uh, would love to hear about what are you most proud of that you've built at the company and kind of what you worked on. And you're obviously very seasoned in this industry, so you've done a lot. But would love to hear a little bit about I think the work that you've done here is obviously very significant, both for the field in generative AI. I think Rad AI uh, has really obviously changed the game in terms of how to introduce generative AI into a radiology's workflow. What are you most proud of based on your teams and your experiences here?
So my role is an interesting one. A lot of people talk about, if you go back in time, early 2000s, kind of like you mentioned earlier, with this whole move fast and break things. There's also been this concept of like 10x engineers, right? So this is actually it's actually a concept I'm kind of against. So the way they define 10x engineer is someone who can put on a cape and can build, that which 10 engineers could build, right? For me, the definition of 10x engineer is a little different. It's where an engineer can make 10 more of himself, right? Can train 10 people to be as good as he is. That's to me a 10x engineer. So for me, actually, the things I'm most proud of here isn't necessarily a thing I've built or a system I've created, but it's sort of getting a lot of the engineers who work across these teams into this mode of being the best engineer they can be, whether it's working with them through architecture of a system or, guiding them through how they might design a feature or how they might achieve an impact or a customer need. Um, I'm more proud of helping them being able to achieve it than I am saying, oh, I went in and built this thing. I have built quite a few things at Rad AI, but the things that I tend to focus on more are improving and streamlining how we build software, how we release software, um, how we can make it reliable and bulletproof. I focus a lot more on looking at the way we do things today and how we should be doing them tomorrow to be able to achieve the scale and to be able to achieve the customer base we want. So I don't know if that answers your question, but
No, it
really
definitely
that's
does.
that's mostly what I'm proud of here.
No, that's amazing. And I think that 10x engineer, I guess, just rejiggering that concept to be able to empower the next generation is so valuable because obviously the work here is just getting started. I mean, I think there's so much more to be done. There's so much innovation ahead. So I think it's amazing that your focus has been so triangulated to making the next generation succeed. Um, Bo, thank you so much for your time today. It was such a pleasure to talk to you about all things infrastructure from product to engineering. I mean, it's been a really insightful conversation for me. So thank you so much for your time.
Yeah, thanks for having me. It was great.